Joe. You're welcome.
I got that test for you before I forget it.
If you want to keep it when we review in class, I'll take it back after thermal class.
Morning.
Good morning.
Sorry. It takes me 5 minutes to get up the stairs.
Oh,
You are still 3 minutes early.
Yeah, if you don't mind, I'm not in a hurry because I'm trying to archive the video file. It's not done yet, so. Actually works out, but not everybody's sitting there anymore, so.
You're good. You got a number noodle.
Oh.
No, this is drawing. And Jeremy, if I send you the link to our Zoom for this, because we have some people online, would you mind pulling it up so people can see you at the front? Okay, I will send it
I'll
to
try
you.
to do this in such a way that it's visible off campus, but kind of hard on some of this.
Sure, absolutely.
I guess I'll give you a copy if you want one.
Perfect. Thank you.
I'll leave you with a few spare in case somebody comes to class later.
Perfect. And I will send you the Zoom link.
That picture I sent you.
I did see it. I haven't gotten a chance to look at Moodle, but I'll figure out why it didn't show it to me, but I'll grade what you put in.
Okay.
It just didn't show up on mine for
And I
some
wanted to
reason.
make sure the timestamp was in there because I did it right.
Joe was here. Kyle.
Is that pond up like Scout Mountain?
Yeah, that's the one.
What we talked about? Where you're at.
Yeah, it's kind of a nice area. I like to go hiking up there quite a bit.
We have everybody either here or online except one person.
Okay, great.
So I think whenever you're set, we are.
Okay, looks like I'm screen sharing. Can you hear me online? Do you hear my mic?
Yep, we hear you.
Oh, looks like I have the speakers muted. Sorry. Okay, try again. Can you hear me online?
Yeah, we hear you.
Okay, great. Thanks. Okay, so let's see. For those of you that are online, unfortunately, of course, I can't give you a hard copy of this, but Mackenzie has digital versions. For those of you in person, you should have a copy of these. I'll try to make this so it's visible best I can from the computer screen. So I'm here to talk about diagrams. Feel free, Mackenzie, if you see something that I might be fumbling around with that I might not be familiar with, if you want to jump in, you're more than welcome to. I'm good with the ladder diagram stuff and the wiring stuff, but as it pertains to a nuclear plant, that's where I lose my knowledge, So, okay, so if we look at this, this is in some ways a pretty typical ladder diagram. I have this ladder diagram up on the front, but there are a few kind of quirks that to me are a little bit different about this one than others I've seen. I don't know if that's because of the age. I mean, if you look at the title block, I think this was signed in like 1989. So it is a little bit of an older diagram than I'm used to working with, or if it's maybe just the idiosyncrasies of the plant. Something I find a lot in diagrams is every diagrammer or every facility kind of has their own personality they put into these. And so switching from facility to facility, you kind of have to adapt to their diagram set. So if you see me fumbling around a little bit, it's mostly about the unique personality of these diagrams as opposed to other diagrams. So I'll work through the best I can. But anyway, a few kind of general features. Have you worked with diagrams much in general or some? So what is this portion right there?
Title block.
Yeah, title blocks. What is some maybe helpful information this title block we might want to know?
Drawing numbers,
Yeah, that's important.
your revision block.
Yeah, it kind of tells you who's approved it and when and that sort of thing. Yeah, those are good information. So it sounds like you're familiar with those ideas. Now they're kind of familiar with or a nice thing on this one. Not all diagrams have this grid A through E and 1 through 8 helps you talk through it. So you can see what part I'm talking about. So I could say, I want to look at B5. You're kind of looking at that B5 zone right there. So have you worked with relay logic at all? So you've seen some relay logic. So relay contact, coil, that makes sense. I'm not expecting you to be experts by any means, but at least hopefully you kind of understand the principle of a contact. Have you worked with Boolean logic at all, ands and ors?
Not yet.
Not yet, okay. So some of this will be a little bit new based on that, but fortunately ands and ors exist in the English language and it's kind of easy to understand from that perspective. So we'll talk through it more. Oh, you did a little bit, okay. So we should be able to make it make sense in terms of like a logic circuit as well. So, okay, so this is probably a review, but basic features of a ladder is there's power rails. And this is something a little unusual. It's nothing wrong. It's just a little unusual for me, is the rails are running horizontal. I typically see them run vertical. Nothing wrong with that, but so essentially this would act like a neutral or a return or a negative. This would act as your hot up here on the top. I guess I should move my cursor so you can see what I'm doing online. So the top line is going to be essentially your power, and your bottom line there is going to be essentially your neutral, or your ground, or your return, whatever you want to call it. We can see the contact symbols here. So these have a lot of different contact symbols. And we see some loads. Now this is one of those little idiosyncrasies I was talking about. I believe these are all essentially relay coils. Now I think they're more than just relays, they're like contactor coils. They're larger relays that'll be doing something like turning something on or turning something off. They're not just coil relays that be used just purely for logic. This is a pretty standard solenoid coil symbol. You don't see it as often used for relays. So again, one of the kind of personalities of this diagram would be the fact they're using a little different symbol for the relay coils. But it's still the same idea. We have a coil down here. It's a load. When it turns on, it does something, right? Let's see. Let's take a look at maybe kind of a simpler diagram, or simpler ladder rung on here. So each of the vertical portions would be a rung. Normally that'd be horizontal. If you think about this as a ladder, we're kind of walking up the ladder, right? Each of the horizontal or verticals would be a rung. Normally it'd be tilted on its side. Just kind of work with this diagram. Let's see. Let's take a look at maybe this rung right here. So we have 4 contacts here and 2 loads down here. What do you think those circles might represent?
Nodes.
Yeah, nodes. So what we call these in my wiring type classes is a terminal, but it's the same kind of idea. It is a circuit node. This is the point at which this is going to be labeled. It's like we got a screw that has a wire underneath it, and there'll hopefully be a label that tell you this is terminal RC2 TBVC-10. Now, without the legend, it's hard to take apart this naming convention. There likely be some logic to this. Maybe RC2 is relay cabinet 2. I don't know that. Maybe, you know. And then TBVC-10 might be, TBVC might be all the terminals in that section, and this is number 10. You'd hopefully be able to find that information in the legend, but without the legend, we kind of have to guess our way through it. But you would hopefully be able to find some terminal labeled RC2 TBVC-10 right there. Does that make sense?
So you said it was a screw with what?
Wire under it.
Okay.
Maybe it'd be helpful if I just Googled an example of a terminal block. Just get a better picture of it in your head.
You've seen terminal blocks.
Those black ones with all the screws on it.
Yeah,
Yeah.
that's an example. Yeah, so that's one style. Since this is an older plant, that's probably the style it has, is something like this. Newer plants might have something more like this. You'd insert the wire in there and clamp it. The same idea. So when you're looking at that diagram, I pull that open. Where did, oh, that might be. It looks like I might have a chat. Let me, why, there we go. Oh, okay, no questions. It's just, I thought I had a new question on the chat. Okay, so anyway, so each of those circles are likely some sort of terminal block that are labeled. Now, I don't know why there's some that are solid and some that aren't. That's something I'd be looking for in that legend. It could be signifying the type of terminal, or maybe it's removable. Who knows? You have to look at the legend. It's not, to my knowledge, a standard thing. But the diagrammer wanted to represent something there. The designer wanted to represent something there.
Maybe it's a fail.
Yeah, or maybe where there's no labels on these, maybe it's something that's wired on a place that doesn't need a label, so it's kind of obvious it's on the relay itself or something like that. But it's hard to say for certain. Okay, so once again, we're looking at this run here. So under what conditions would these loads have power? What would cause these loads?
Any of those contacts are energized.
Yeah. So why is it any one of them instead of all 4 of them? Well,
They're in parallel.
yeah. So that's an important idea with ladder. The idea that parallel essentially acts as an OR. Let's see, I guess I can just write this out. Every one of these classrooms I'm teaching in this semester is different, and I'm trying to get used to going back and forth. I guess you've seen that in the building next door. So what would act as an AND?
Both of them. Series.
Yeah, series. And then what about not? What would be the equivalent of a not on a diagram?
It would be 2 normally two normally open in parallel?
Well, if you think about it, with a NOT, you only need one input.
Or one normally closed?
Yeah, one normally closed. That's all it is a normally closed. So that is a NOT.
I didn't think about that.
You got there. So if we have ands, ors, and nots, we can get to any logical function, at least any discrete or on-off type logical function we need. Might take a lot of them, but we could get there eventually. So in this case, if we wanted to write this out, this rung is, maybe we just give it some labeling, call this A, B, C, D. You know, if we want to be technical, we'd label R6-15-1. That's the relay it's coming off of. R6-16-1, R6-16. So it looks to me like we have R6, 15, 16, 17, 18. We have a relay 6-15, 16, 17, 18. The last digit might be like a contact number. It might be a terminal number. It's hard to say. But we have 4 different relays. We could call it A, B, C, D just to be simple. We can say out is equal to A or B or C or D. Just recognizing that A, B, C, D represents something a little bit longer. Or if you wanted to write out in Boolean logic, it'd be A plus B plus C plus D. Have you seen Boolean logic written like that? Some of you are nodding yes, some of you are nodding no, or shaking your head.
I don't think so.
Okay, we'll ignore that then. This is just saying the same thing. It's just a mathematical way of treating it. And in some classes, I'm just not sure which programs cover it, which don't. Apparently yours hasn't, at least.
Sherry went over a little bit, but we didn't use that very often. It was just like she mentioned.
So something just as an aside, kind of one day and you were done. Fair enough.
It wasn't much, yeah.
If you understand this top part, you understand enough. You know, there's no need to treat it mathematically. So A or B or C or D. And of course, we look at that diagram, that would turn on which of these loads?
Both of them.
Yeah, both of them, because they're in parallel, right? So if we get power to either of these points, we get power to both points, right? They're connected in parallel. If they were in series, they shouldn't be in series, first of all. We wouldn't necessarily have power to both. Loads, though, are typically connected in parallel, not in series. So we'd have both power to R8-2A and R8-2B. Okay, let's look at another one. Let's look at the next one here. So we look at this rung. Under what conditions would R8-9 run?
Yeah, it would be one of those top 2 contacts. Oh, it wouldn't.
That, okay, you're partially there. That's partially right. One of the top 2 has to close.
But it wouldn't. That normally closes program.
Well, if you pay a look, they're labeled slightly differently. So they are kind of tied to the same system, but they're not directly interlocked, I guess. So let's take a look at this. Maybe if I can annotate it if I put it over here. There we go. So you start off by saying one of these 2 contacts has to be closed in order for power to get through. That's fair enough, right? That's true. So we just maybe label this A, B. So we can say A or B has to be energized. But what else has to be true?
The other reset reverse, does that have to open?
Yes. Well, it has to be closed, I guess.
Or, yeah.
And the way we'd phrase that is and not, we could call this maybe C. So as long as C is not energized and either A or B are energized, our output's going to be true.
Well, if A or B is energized, won't C automatically become de-energized?
No, not necessarily.
Control relay, remember?
So if you look at the relays, this is K29-3 and K39-1. So they're not necessarily electrically connected together in the relay coils.
Right.
So they might open or close in different conditions. Now there is logic. It says manual reverse, reset reverse. Those are 2 different, those are, and it does kind of sound similar. Those are going to be 2 separate relays, 2 separate functions. Does that answer your question? So to me as an operator, I think it'd be useful to be able to go through and say, okay, I need this relay to energize. Why is this relay not energized? So I can come back and say, okay, I'm looking for this contact needs to close, or this contact needs to close, and this needs to close. In order for this to close, the relay has to be off because it's normally closed. Now allow you to sort through, hey, why is my system not powering on like it's supposed to? Now, chasing down where this relay is and what function that is, you have to go to another diagram to find that relay. That could be tricky. You could be going back and forth quite a bit. Go ahead.
So does that represent a load on the bottom?
Yes. So that bottom here represents a coil. Sometimes it's shown like that instead.
Like a control relay? coil?
Yeah. I think what they're trying to represent is where it's a zigzag. It's like a larger contactor, which is a type of relay.
That one says R8, and then up here we have an R8. So if you're to close that one up there, wouldn't it open your reset? Oh, no, never mind.
Well, that is a good point. So that's R8-9. That's probably a contact associated with R8-9, and that's the first contact. I suspect that's what's called a latch.
Yeah.
So just like 3-wire control.
I would expect
Makes
the
sense
manual
now.
version to have a latch.
Yeah. So we could say, modifying that statement. We could say maybe if, let's see, if we call that A, this would also be A, and we could say A equals A or B and not C. So if A turns on, go ahead and set that to true. Would you prefer the lights off or the lights on? Good.
It's really hard to see.
Yeah, let's-
off.
I think it's the red, we had like a blue or something.
Yeah, I have a very limited set of colors in this program.
Use
so-
black.
That's better, that's good.
Okay.
It's black on this.
Yeah, the red shows up nicely on the white, which is why I picked it, but not so well on the black background. Okay. So yeah, so it could be interchangeable with that. And it does look like, once again, you'd have to double check and make sure they're based on their numbering. But it does look like that's a latch contact there. So the output's true when either the output was formerly true or this manual reverse is energized, and as long as the reset reverse is not energized. Does that make sense? Now, of course, it can get a whole lot more complicated. Something like this run right here, where we have a whole bunch of logic. So in this case, it would be this has to be true, and then a whole series of ors here. Lots of possible conditions in which it could be true. So it could be this one and this one, or this one and this one, or this one and this one, or this one and this one. And it gets really hairy here. It's like this one or this one and this one or this one. And so you'd have to, it'd take quite a bit of time to working through that. But hopefully you at least get the feel for, we need that power to flow through there. And there's lots of different ways to do it. The series acts like an and, the parallel acts like an or. Everybody good with that? Any questions on that? Oh, go ahead.
So we talked about the power and how your neutral would be on your bottom leg and your positive would be on the top. Never mind.
You figured it out? Fair enough. Trying to think if there's any other features on this particular diagram I wanted to look at. One thing that kind of puzzled me, I was kind of mentioned to the side, is X and Y. I'm not sure if they were trying to say this goes somewhere, if this maybe connects there and they didn't have room for it or what. Because I don't see any X or Y labeled elsewhere in the diagram, but it's kind of peculiar to me. Go ahead.
So in case it mattered which picture we're looking at, one above or below, if we're looking at a schematic that was turned.
Yeah.
If it would matter, and I was looking at this, would this be below? You know what I'm talking about? And if it was in a sequence that it needed to go off
So
top to bottom or whatever, you know what I'm saying?
with relays, that order doesn't matter. It's all in a big parallel circuit, so it'd just be a matter of timing. And it just kind of would be luck of the draw which hits first. If you were looking at two things, maybe if A turns on first, it does something. And if B turns on first, it does something else. It'd just be a matter of essentially luck.
Okay.
Now, if this was a program, typically it'd go top to bottom and run through the program. This is an actual hardwired relay, so you wouldn't have
I
that
think
feature.
I'm mixing the ladder or the PLC stuff.
That is easy to get that confused. The logic is very similar, but there's a few distinct differences that make it a little different. To kind of, it's, I tend to find students in my class tend to get a little confused with the PLCs versus relays because they do work a little differently. But, let's see. Any other questions about this particular diagram? Okay, let's look at the other page. This would be the back side. Now this will be a little harder to say under what conditions things will start and stop because we'd have to have a little more information about some of the components in the system. But we can talk through some of the main features. So the top, we have this auctioneer cabinet. So we have a power supply. What are these symbols?
Diodes.
Those are diodes. So we have 3 diodes in series. There's kind of, normally you wouldn't think about putting diodes in series. It's just going to pass through each of the 3, right? But I think what they're trying to do here is trying to develop a large enough breakover voltage so that it doesn't always switch between power supply A and power supply B. It's trying to, so essentially a diode has a breakover voltage where it has a minimum threshold at which it'll start conducting. And I think they're just tripling that by having the diodes in series. So essentially we can get power from either this power supply or this power supply.
Without them traveling.
Yeah. So the idea is it would require this one to be substantially higher than this one before it starts conducting through the diodes. But to verify that's exactly how it works, you'd have to go to the diode part number if you don't even have to verify it has a breakover voltage that's a little high. But that's the only reason I could think of to stack 3 diodes like that without having like a rectifier or something. So I think that's why they have 3 diodes. Anybody happen to recognize this diode symbol?
Zener diode.
Yeah, what does a Zener diode do?
It stores up and then at some point it lets them through electrons.
You're kind of close to the right again. So it doesn't conduct until a certain voltage.
Right, yeah.
And then it kind of clamps down on that voltage, right? And it stays at that voltage. So it acts like a voltage regulator. So since this is producing 150 volts, if you read right there, 150 volts, likelihood is this is a 150 volt Zener, and I try to keep the voltage right at 150 volts. If the voltage is too high, it's going to start conducting and pull that voltage down. Just for filtering, basically, smoothing. Anybody have not an idea why we put this diode in here? It's a standard diode symbol, right?
It won't conduct if the electricity goes from the top to the bottom, will it?
Yeah, it shouldn't conduct under normal conditions, right? This is what we call like a flyback diode or something along those lines. If we have an inductive load and there happens to be a little bit of a negative voltage on the positive, it'll conduct and try to pull that off. So sometimes when loads turn on and off, relays are inductors, right? And inductors store energy. So it can cause little kicks and spikes in your circuit, and that would conduct in those negative spikes. That makes sense? So you'll frequently see those around inductive loads. So they put one at the power supply instead of the load. That's, again, flyback diode. There's other terms for it, though. We have some over and under voltage relays, enunciator panel. So to me, it looks like it just reading voltage off the power supply here. And then it puts out a signal if the voltage is too high or too low. Pretty straightforward. Presumably there'd be an operator panel with an alarm and a light that go off saying, hey, high voltage, low voltage.
So if I was drawing that symbol, why would I choose A56EA? Is that for them?
Presumably that's a label they'd have on the enunciator in their panel. But once again, this is one of those I'd have to get a feel for the entire set of documents with the legend on the front to verify, but I think that's pretty reasonable speculation there. I can say, as far as I'm aware, diamond's not a standard enunciator symbol, but it's something that made sense and works for them, you know, so. Maybe it's a standard in nuclear world, I don't know, but for ladder type or wiring diagrams, we typically don't use a diamond for that. We might use like the indicator light symbol or something, but anyway. In the end, it's really, you're trying to communicate information, and as long as it makes sense to the person that's reading it, that's the important thing. So go ahead.
Those little like hot dog looking things.
Like this?
Yeah.
Okay, so that's a cable label. That would help you track down that cable. So that's cable 3036-2A. So there'd probably be a label on that cable that if you're looking to trace that down as an electrician or something like that, if you want to be able to replace that wire, it's going to be really useful information right there. So you can see it's terminated at terminals 5 and 6, the over under voltage relay, and it's connected to cable 3036-2A over to 8056-DA. It's a good question there. Now, see this dash line? Anybody have an idea what that dash line would represent? Yeah, it's a panel or cabinet. It's kind of an enclosed area, separate area. If it's a piping instrument diagram, it might be like a skid. In this case, it's telling you this is all an enclosure. So we'd be looking for all this in the same location. Now here's something, and if somebody thought of an idea here, I'm trying to guess my way around. I see this 24A, 27A. This appears throughout the whole diagram set, and it looks like something that it just assumed that you know what you're dealing with if you're working with this plant and this diagram set. The only thing I could think of is maybe it's like indicator lights and buttons and such on their panel. That would be indicator 24A or something, but I don't know. That's just me guessing. I could say that maybe it's where it connects to another diagram, but usually you use this symbol. They do show this symbol elsewhere. So I don't think it's a connection to another point on the diagram, but it's hard to say. You know, it's I wish we had the legend here so we could kind of sort through that. It also is possible maybe, I don't know, I just can't, maybe it's a bus, a terminal bus. I don't know, it's something that kind of puzzled me. Mackenzie, did you have any thoughts?
No, I am not used to seeing it that way, if it's an annunciator or a push button on the control panel. But it could be.
Yeah.
Because there's going to be clutch controller panel in the control room. I'm not sure what that is either.
Okay.
They didn't send me a legend. I can go back and ask. They do have a couple other things here.
Yeah, I'm kind of with you on that. It's not that, you know, I don't necessarily need a legend, but this is my ignorance. I don't know what that's doing for us in the diagram. So
I'm used to seeing the push buttons and the annunciators be either round or this diamond.
fair enough. So the diamond's kind of conventional on nuclear. Fair enough. Yeah, and I've seen this quite a bit for page connectors, so I don't know why they would use a different symbol for like a page connector if that's what they're going for. I tried to think of it, maybe it's a common bus or something like that, but that doesn't make sense because they're tied already up together here. Why would you need to show another bus symbol down there? So I don't know. I guess it's one of those things we just don't know. It's probably connecting somewhere else and somewhere else, who knows?
Maybe a secondary indicator panel, and so they're trying to show the difference. So the diamonds are the ones in the control room where you'll see the annunciator. And
Yeah.
that's somewhere else in the plant where you might have an indicator.
Like a local panel or something. Okay, that would make sense.
Possible.
So anyway, that's something I wouldn't be looking for in the legend if I was out in a plant trying to figure this out. Maybe if you could walk through the system, you might be able to find it, figure it out as well. But in any case, so essentially that's our power supply. Now we have each of these modules. So let me zoom out slightly. So there's 4 different modules. Once again, they're enclosed in a dashed line, so it means it's kind of like a unit in a cabinet or an enclosure or something like that. We have 4 different cabinets. And then we have this RCCC module, which if you look at the bottom right, it gives you an abbreviation. Not bottom right, right-hand side. RCC, yeah, rod clutch coil controller. So I think it's some sort of electromagnetic coil that if it loses power, it drops the rod. Is that correct? Okay, that's about all I know about that side of the thing. So essentially we have 4 of them. Now, to figure out exactly what these labels are, as a technician, if I was trying to figure out why this isn't working, I'd get out this diagram that's referencing. I'd also try to find a manual to figure out what does this H and L mean? What does this NRS mean? We have to just kind of guess our way through it. We don't have a lot of information. What I can say is when we have a box like this, it's just a matter of inputs and outputs. Each of these points is going to be some sort of input or output on that device. Might be a power input, might be a signal coming out, might be a signal coming in, but just showing where those signals connect. So I guess this is kind of showing some of the limitations of just looking at one diagram at a time. You know, you'll only get so much information off of one diagram. But in any case, we can see that there's some sort of module here that controls that rod clutch coil. We think this symbol might be.
It's a transformer.
That's a good guess. This can represent a coil, which sometimes can be used in a transformer, but in this case, it's not a transformer.
Just a coil.
That is a coil.
Oh.
What's right next to it? Yeah, so if we have a contact and a coil right next to each other, what might that be?
Relay.
Yeah, so this is showing it's a relay package. So you don't often see it like this, especially when we have other symbols. What they're showing is this is just a package relay altogether. So this coil comes off of H and B. We have contacts here. So I would guess that this is either indicating maybe that clutch coil is energized or maybe de-energized. That's just a guess. You know, we don't know until we get into this module A1 and figure out what exactly this does and how it works and what the terminals H and B does.
So where would that normally closed leg be going?
So it's saying MC means no connection. It's just an option you could have for something, but when they wired up, they designed it not to use that MC contact. So MC being no connection usually. It could also be referring to normally closed, but in any case, it's not connected, so it will also make sense that it's not connected. So now if you look at this, this is kind of interesting. If you follow this line, 9 comes down to this, what is that, S? So S comes up through that contact, and it goes down through this contact and comes into this L. Now, if I had to take a guess at this, this is a guess, essentially what this is doing is basically if either or of these drop out, they're both going to drop out. They're fed in a series loop, so if it sees them both in that loop, which makes sense to me. You know, if you have one clutch coil de-energized, you probably want them both de-energized, but it could be something else. So it could be some other function. That makes sense? So if we look at some of the other stuff that's attached to this, we have this N and R comes out as a cable. It's hard to say what this is. It's some sort of output. It could be going to, let's go to another diagram. It could be an output that's fed into a relay or something that's controlling something else. We have an input over here. This could be a command signal for something else. This could be what tells the clutch coil to energize or de-energize. But without knowing exactly how this module A1 works, we couldn't tell you for sure. We can't tell for sure what to do. Let's see. I'm trying to think if there's anything else interesting on here. This is kind of a unique symbol. I thought I'd point it out. What do you think that little D triangle represents?
Diode.
Not a diode.
Delicious.
Diodes can be triangular with a line, right? But it's not. This is kind of quirky, but it's a ground symbol. I don't know if D means like a digital ground or like a data ground, but it's just representing a ground. I think they use a D to represent it's a different ground than some of the other plant grounds. And if you look, it's on the negative line. So that would make sense that you might want to ground the negative at some points. So again, I just thought that was kind of quirky, so I thought I'd point that out. Okay, this is a standard symbol resistor, right? What do you think this might be? Anybody have any ideas?
It's a diode.
So we have kind of a transistor and a diode. What do you think the little lines between the two might represent? So if we have diodes with a light coming out of it, what does that represent? Yeah, it's an LED. So if we don't have a third leg on this transistor, what do you think this transistor might be activated on? Yeah, off the light from the diode. This is a unique component called a photocoupler. So if we want to really isolate circuits from each other, we can use an LED and a phototransistor to transmit via light. There's no electrical connection between the two. It just turns on and off based on light. So if this LED is on, it's going to fire this transistor. So that's all it's doing is signal isolation for us. Let's see. Anybody have an idea what those clouds might represent?
The revisions.
Yeah, revisions, future changes. I always think about it as something you're dreaming up, you know, for the future. That's how I remember it. But in any case, it's something that's going to be changing in the future. Mackenzie, do you see anything else you wanted me to point out? That's as far as I can think of, as far as based on my knowledge. If I had more information about, say, one of these modules, I'd be able to explain it. But
No, I think that's good. I know some of the questions that we were trying to show that you guys had was looking at and understanding where power was coming in on the drawings.
okay.
I feel comfortable about that after hearing these explanations. Well, this one's clear. And then the drawing side.
Then now that we know that the positive wire and that's the negative wire. I always forget that I should be looking at it like this.
Yeah, that's more typical. It helps you think through it.
Have you ever heard, so like, as far as grounds go, have you ever heard white called as like grounded and one's grounding?
So white, if you think of it as a neutral is grounded at exactly 1 point, so you have a ground and neutral connection. So that's probably where they're getting that from, but it's hard to say without knowing more of the context.
I think that's right.
Okay.
When I talk to people and they say that.
Yeah, the idea is you want the neutral to be 0 volts, and the way you do that is actually sink a ground rod and tie it at exactly 1 point. You tie it at 1 point so you don't have a ground loop. You tie it at 2 points, you might have current flowing through like a panel or something like that. So, any questions about the diagram while I'm here? I guess something I didn't point out, if you look, C connection below, so this is a continuation, it connects down here. I think that's kind of obvious by looking at it, but again, on the top right, it says C continuation below. And it's just showing it continues this diagram here. Okay, well, hopefully this is a reasonable coverage. I know this is a little short on time, but I don't know if you were looking for some specific time slot or.
No, this class session, we actually have 2 hours. But I think if everybody has got their questions answered, I think that was great. I think that way of showing it helped remove all the confusion from my mind.
Fair enough. I hope it helps.
Do you guys have any other questions while Jeremy's here?
No, we know where to find it.
Okay. Okay, everybody online?
Oh, I might have a chat question. Let me check.
Yeah, anybody online?
I swear.
So are you looking for a ladder diagram or do you want like a schematic of this?
Our drawing lab, it'll be Laura schematic.
Okay, well, if that's it, I guess I'll stop share and I will see everybody Friday, I guess. So yeah, tomorrow. That's right. This week's going by quick.
His problem was my difficulty in figuring out what Mike had taught previously, which is why sometimes I have no idea what you guys have learned, and also why I have to create so much. As I think he just wasn't a person who wrote stuff down. So he'll write a couple of vague sentences, and I'm sure that that made sense for him. And I have no idea what he actually taught based on the couple of sentences.
It's all GERD, yeah. What? Which went through GERD.
Okay. Yeah, for sure.
Yeah,
And
it,
then I think the next semester was you, wasn't it?
because like I spent a week covering GERT.
We talked about GERD a lot.
Yeah, we're good experts.
Because I mean, GERT is GERT, and you're going to be rad worker too. So, and I have a whole class to go over rad worker too for a whole semester. I don't know.
So, I did.
Okay.
So I talked to my friend at MFC, he had to retest Red Worker 2 anyways.
You have to take it
Is that everywhere? Well, I mean, upon
Ev-
getting hired.
Between every year or 2 years, you have to renew it.
Well,
And
he
so-
got it with the program here.
Did he get hired immediately when he graduated?
It was like 6 to 9 months, yeah.
6 to 9 months. It might have just been that it had been so close to his renewal deadline that they're like, hey, just go ahead and join this new hire group that's going through it. Because that's cheaper for them, right? If you join a group that they're already paying for it. The graduates last year who got hired, none of them told me they had to do a recertification. So if it was 9 months after graduation, that's almost at the 2-year mark, right? He'd be within a quarter. And so MFC might have just said, you're within the quarter that you need to renew it, and here's a group that's going to do it right now. Just join them. That is entirely like something INL would do. Okay. So for the rest of the class time, you guys are free to work on your drawing. Since it was supposed to be drawing lab time anyway.
When is this due?
Thursday. Thursday at midnight. Because Tuesday we have one more drawing lab. So you have one more time to work on it in class.
Is there a section of the DOE handbook that has a little bit of this stuff in it? That stuff?
Yes, it's from the assigned reading that we
Oh,
went.
okay, I remember now.
There's a section on electronic diagrams and electrical schematics.
So do the main line power and it circuit, do they connect anywhere? Are they supposed to connect?
They are supposed to connect, yeah. So you're essentially gonna have to step down to what actually comes in and what the control circuit uses.
Let's see if I'm correct with everything to this point. Okay. And I haven't left that now. I don't know if this is right now because, but let's start. Got my charity. Okay, so we got 3 of you going in, 3 carries, this is your 9. Okay.
120?
The 2 fuses for 4, which is down there, but it's 2 fuses for this. Yeah, I got my 2 fuses for you. 2. We don't have that, so we don't have to worry about that. And then that's 120. It's coming into one phase. Do I just go off? And then start a ladder diagram? That's how connected to, that would be what I expected. Which I figured. Supply by the transfer, 10,000 turns. Do I need to do something for this transfer? How do we know that it's, we're just assuming that it is?
So I think if you look,
And then typical motor starter. Didn't let me find some for that because I didn't have one. The motor is provided. This is what my big question is. I don't know if that stands for something maybe low voltage protection. I don't know. It must have something to do with like all these crosses. Each one of these means something.
You just use an open switch
Did
for
I?
your switch?
okay, give me 1 second. 'Cause
Okay,
it-
that's what I thought.
I know there was something like that Sherry did.
Yes.
Was that all that
Did you-
old
did you see the-
information?
The
Yeah, if I was
ratio
showing the 3 phases, I would do the
turns of wire, right?
Okay.
Do you remember doing this with Sherry?
Something similar.
Yeah.
It was, first semester.
So here's a step down, right?
Because this would be a step down.
Right?
It'd be 4 to 1, I believe. It was 480 volts, 400, that was 4 to 1.
120. So you're gonna go. So I think by showing this, right, you're giving the same info, but you can also do this ratio and show 1, and then they'll be able to calculate that. Right, so it's just,
So I know this is 4 to 1. Are you looking for me to put 4 to 1 right here?
so then you got 10,000 turns and it's primary, right? You got this and this. They should know how many windings you need to go between those, right? But you can also do this ratio and figure out how many windings you have to go to the secondary. So essentially you could show it either way.
So is this correct, kind of leave alone if that good enough to show
Yes.
me the 4 to 1?
You can, yes.
Okay, I just want to make sure it's covered, so I
Yeah.
don't get a mark there. Oh, and then
So I think there's a couple different ways to do this. Let me see if I can find a. I can do it. Yeah, surge protector.
So that would be this part right here, so I don't need, it's done. Contacts, some kind of a protection. for the
Yeah,
motor.
so here we've got, like here's a symbol for a surge protector.
So would you put that behind here then? No, it has to be after here.
Yeah, it'd be up here, going towards the,
Tap in between these. And this,
yes.
so I need to come up with a symbol.
Yeah, I'm just trying to see if there's a standard one somewhere. Oh, these are terrible images.
So that doesn't mean the same thing.
It might. I'm trying to
That's what I'm
see.
thinking it does, if I remember right, but you'd rather me use that.
No, it's fine. I don't have a preference. We just have to find somewhere that gives us.
Okay, Hayden has a different
So
symbology.
here's
That he put it.
okay. There's a couple surge protectors. Here's a couple surge protectors. One that's yours, yeah. Little gap.
Okay, so I
Yeah,
got that.
so you're
done.
fine. Yeah.
Now I can move on to this. The pump motor requires minimum 10 gallons per minute for cooling water to be
Yeah.
to
So
stator.
right. So now this part, right, would be some sort of probably ladder diagram, right? Where you have some input, and even that can be turned on.
Let's write that ladder diagram down here. Gonna talk to it. Connected to control relay. And headed to top. So this down here, you're gonna have this in whatever your latch, your relay. That relay, I guess essentially is what we're talking about. Right, that's
And
not
then
turned
also
on.
make sure that we're and then you step down to control. Yep, and now these are the things that you need to have in your control. Right?
This is, okay.
Did you have a question, Joe?
Yeah, I'm real patient. If anyone wants to talk to you first, I don't really know what I'm asking. I guess I want you to look at that. See what kind of garbage you think it is. You know, this stuff down here is not really necessarily my final placement. I just wrote them in so I wouldn't forget everything. And I mean, you said you want a schematic. Well, that looks like a ladder diagram. to
Yeah,
me.
so it's gonna connect to the ladder diagram that shows your actual
And
control
then are
circuit,
you
right?
using contacts?
This is how it's
Switch?
you've got your knife switch, you've got your
Or is
actual,
this
and then
nice switch?
I think you're missing a piece up
So
here
you're doing it before.
because this powers the actual motor, right? So you're gonna have to go to some sort of like motor starter.
Yeah,
Right?
okay.
And then here, if you're gonna come down to your control circuit, then we're gonna have some protection, but then we're gonna have some conditions we have to meet, right? We have to have some flow, and so there's gotta be like a relay. You need to
Mhm.
reach that flow, right? And then if you have deviation from that flow, you're gonna close off power to the pump,
Right.
right? And then you have to have some temperature indicator that if it's in this range, you've got power to the motor through your control circuit, but the motor turn off if it's above or below, right? And it won't start.
Yeah, I'm
as well.
not really there yet. But I guess I'll, so when, I guess I'm not really sure what difference between a schematic and a ladder diagram really is. I mean,
They're really not all that different. It's just that here, you're showing some physical components, right? We're showing that we have a knife switch. We're showing that we have these fuses, right? And then here, kind of like PNIDs, they do show the pieces that are in the piping system. They also show that overall flow. You're kind of now showing our logic that allows this to actually turn on.
Yes.
So that ladder diagram is kind of the pieces of the puzzle that say if this and this occur, it turns off. But
So,
before it turns on, it needs this and this.
so this part is a ladder diagram, and that part is the schematic.
Yes. And they connect because before this power can continue down and actually turn on the motor, you have to follow this logic. Does that make sense?
Oh, kind of.
Okay.
I'll keep working on it. Thank
Okay.
you.
Yeah, it looks like a good start.
So I can use these as my fuses, right? I don't need those little boxes that look like batteries.
You can use that symbology. Yeah.
Okay. And would this be, because I was looking at Catel's and I had my knife switch over here.
It doesn't really tell you
Where it's
that you have to do it a certain order.
Okay.
So that could be acceptable, right? You get a little design say in your drawing, because it doesn't tell you specifically they have to be on one side or the other.
Okay. And so this is pretty much my primary. I'm done with my primary time, and now I just have to do my system requirements for what this system is. Exactly. Okay. So this drawing is going to be a ladder diagram.
That's correct. I mean, I guess there's probably a way you could find to show it as a schematic that would technically meet all the requirements. But I think using a ladder diagram there would be the easiest and most straightforward.
Well, schematic does not have logic.
It does.
It does. It's just, you're gonna try and lay it out how your control circuit is actually physically laid out. And so now,
Schematic.
yes. Whereas a ladder diagram is gonna show the flow, right?
What's LVP?
Low voltage.
So would that be a zener diode?
That'd be a way, I think Kel and Kaden were thinking surge protectors.
I wish I need to go back and find all this stuff. That's so happening, I ripped up a bit of that semester.
Ripped it up?
So,
You gotta save that until you got your degree.
I know, there's a few things that like, I will never have that class again.
Yeah.
I'm gonna have to listen.
It would kind of matter to choose what you're actually worried about with the voltage protection, right? The diode would be more if you're worried about that changing direction and having negative currents.
Stops the negative.
Right. And so if you're worried about too much of what is supposed to come through, just coming through in a surge, you use a surge protector. If you're worried about it changing direction, you use a diode. It doesn't tell you what you're protecting against here. So either method would would be acceptable. But you pick based on what your actual concern you need to protect against is, right? Does that make sense?
Wouldn't the surge be like more voltage?
Yes. Though sometimes you can use a surge protector for undercurrent flow as well, right? You got too little to keep something energized that you need to, right? You can have something earlier trip to keep that protected.
I did contact.
So just kind of, you have some freedom for how you want to do that. In my mind, when I read it, I went to surge protector, but diode, like, yeah, it could be that they're worried about opposite flow coming through rather than just too much coming through. It doesn't really say. That's probably something I'll specify better for the next class that does this.
Is the 10,000 turns of wire just extraneous information, or is that a way to represent that?
It's giving you options for how you represent it, right? You could either put in this actual volt to step down, or there's a ratio between the primary and the secondary, which you can find out because you know 3 parts of the 2 ratios, right? And you can solve for how many turns of wire will be in the secondary and show that ratio instead.
So you would like it labeled for what it is, the transformer? Or
You can label it
or
either
you
way.
just say 480 here and 120 there?
You can do that.
But
Or
I
you
could-
could solve for how many turns go in the secondary and then show that ratio of primary to secondary turns. Both are acceptable ways to label it. So it's just kind of giving you enough information that you could make either choice.
You probably like both, wouldn't you?
I'm not too worried about having both. You can pick one. But if you look on a symbol and see that ratio instead, it was so nobody was confused about why some are that way and some actually show the volts.
It's a portable. I had to do the math.
How do you know?
What's your relay?
480.
I'm joking. Being a moron.
But it literally it took me a second. I was like, 120 divided by 480. That's not right.
Because your relay is acting like a motor, right?
The relay is contacts and coil.
Your load could be. And what part are you trying to do? That first one. The pump motor requires a minimum of 10 gallons per minute. Yeah. Water. So I would do a flow switch or float switch. And once it reaches that 10 gallons per minute, it's gonna start the motor. Right? Right. I still have something more on mine.
Just make sure that that alone can't start the motor, right? Because you need flow and temperature, both, before you can start it, right?
So then you do temperature and flow switch.
Yeah. And just make sure it's
And that would be an and.
and, exactly.
I have 3 more and. You do? Yeah, I have those off my computer. I didn't think I. There's some programs.
We
like
could
that.
use do more for instructors for that.
Right, right. I just Google my. So the surge protector would go after the motor on the primary side? It says the motor is protected with LED protection circuit.
So I would expect to see this before you connect to your ladder diagram to the control circuit essentially to ensure that nothing,
It would be on the primary side of it.
that's what I would expect to see, yes. If you have a really good reason you would do something else, I'd be willing to hear it. But I would expect with this wording that Mike was trying to say, that'd be before it gets to your control circuit.
But would you put a surge protector before the motor or after the motor?
I would put it before. Yes.
Those people that have down to my surge protector. Or the motor. And that's the key to install. Or most of the case. Down to the space.
That's a surge protector.
Oh, that's overload.
Circle, arrows pointing to it, and dots. So you didn't,
Ice contacts and
those need to be normally open, right?
No, because when it breaks, I mean, at those temperatures, above 40,
Pump and motor
or 180,
are
I think
oil to be maintained in 48 to 180.
when it
So
goes
if it's
below,
not within that, those boundaries,
above,
shut off the motor.
Yes.
Okay.
So if it goes high or low, it'll shut off and it won't start until.
Oh, okay. So
The
it's
book.
like a start and stop.
Yeah.
So for that,
So it has to get up to that temperature before it will start, and if it's operating and goes above or below, it will also stop.
okay.
okay. So here I marked it, and that's what I did down here. So I got rid of that. So just, that was gone, that's what I have.
So.
And then I skip below and I can put,
Here. Okay. Go down some.
there's my fuse that protects,
Here.
low voltage, and this is my overload.
Okay. Good. And then,
So when this goes off, that'll close, turns that on. When that opens and energizes, or closes and energizes. What is this? What am I
that's
looking
what I'm asking. Yeah.
Oh, 10 gallons per minute.
Okay. So
That's
this is
what I need to
your
label.
flow.
Right.
When you have that flow, that turns on.
I have that then.
Okay. So if
So
it's,
CR1 and CR2 are energized. I'm working at CR3 now
it has to be above this and below that.
to operate that,
Operate that.
which will energize that, close that.
And these are and.
Mhm.
Yes. 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 Yeah.
Okay.
Sounds good.
I'm gonna put it on graph paper and then send it in. Am I good?
The only thing I'm not seeing.
What do you want me to put in there? I'm good. I just don't understand the volt or the surge protector. So I can put a 2 amp fuse here. I also put 2 amp fuse here.
Right, so it does say primary has two fuses, right?
Right, that's the upper leg, isn't it?
Yep. those are
2
these.
amp fuses.
So here,
That is, I would just put a fuse in there anyway, regardless of, well, that's just the way we've been taught. Put a fuse there at the entry.
and that's pretty standard. So essentially, with the surge protector, what it's saying is that because now you have a system over it, you're probably very to pump. You don't want a bunch of power to come through here, turning things on when you don't have real
Right.
signal, right? So,
So that's the point of that and that, right?
yeah, so that would be,
I'm double protected and up here. So I'll look up the surge protector and see how to draw it and how it works. I mean, it's the same thing, I get it, but I'll learn how to use it. And I'll use it. Or if I feel like correcting it, I don't know.
And then on one side, I see that you kind of have your arrows, but like you're connecting to the motor starter, right? Like that's
Yes.
ultimately where we're going.
Yeah.
So I would expect that to be
Motors
explicit.
Should put MS.
Yeah.
MS in a circle, just like I would put it in the diagram.
Mhm, mhm.
It's not labeled.
CR1.
I just want it to energize when I hit that green. And then I go to CR1. CR1 will energize. And I will close that. Requires M for flow switch. And then I'll go across to CR2. This is it. Well, try to end it too soon, so I like that. So CR2 is energized. CR1 and CR2 are energized.
And that's like level.
So then I go at my outboard
I get it. You don't have to explain it to me.
Up at that first floor.
Oh.
It's not gonna work, no one would use.
So now
It won't close.
with all three of those conditions, I can still have one.
It's right in there. And I'm like,
But she has set the conditions up there, so
Get rid of
what
it.
I'm doing is going through logic, like, okay, so I have a contact and a switch. And then you can't have a load on this side, can't have control over on this side. So you wanna go from one control
Remember all
relay
the symbologies we have for this?
to
And I thought it was
another
like the
one.
arm down with the really huge.
Well,
might be right.
I guess I don't put CO2.
I was trying to.
That's
look at
interesting. I was gonna say, I guess I could still see how I could see how one down here.
Yes, you're right. It's like,
If she wanted to.
How did we do our overload
and
last
fix
time?
that.
Overloads, remember, they were on this side? Yeah. Oh, they were on the other side of the. So then what is this?
So this is your motor starter. Once that motor starter connects, then you get connection. So that is the surge protection, the LVP. I don't know how to use surge protection. I don't know what the thing is right now because I got my phone off my computer. So what I did was, she said it was okay to use the Zener diode, which you have to have so much before it lets it go through. So then, once I get all that, or if it's underloaded, I will be. It's gotta work properly. But you go down, once you hit that switch, all these are gonna be, well, this is not gonna be running. This is gonna be the only thing that's flows is the temperature, right? So you'll have one, in real life, you would have one contact. Well, when you hit that switch, that contact's gonna put, boom, CR1, CR1's activated, CR1's activated, close. So now, this
Oh, I have my
happens
temperature
after a minute, activate CR2.
Well, look at that leaf.
They're all conditions from the relays that.
So if it's,
And.
if it gets over 180, it'll open up. Or no, if it gets over 180, then it's closed. And open it, shut it off.
I'm not gonna lie, until
Once it hits 40, then you're able to start it. And it'll stay running until.
Yeah, because until it goes above that, yeah, because once it gets to that temperature, and then there's the next. Yep, yeah.
Right. You gotta understand where your conditions need to be set.
I think they're doing it with that. When we converted it over to doing it on Gilmore,
Yeah.
so I should just stick with Sherry's original.
You won't confuse me so much.
I'm actually.
I don't need that at all.
What do we have tomorrow morning? Right, it's.
Materials?
Materials,
The-
components.
No thermal.
Nope,
And process control measurement.
Today's thermal.
this, the, yeah, nuclear careers.
Oh, can I schedule a moment with you during one of your breaks tomorrow or today?
Yeah, so when this
Well, you
class,
have careers that apply on our system today.
yes, but that gets done at 2, and I have an office hour from 2 to 3. You could come by then.
Oh,
Okay.
can I be here early Friday?
That's
Maybe
fine.
like 10 minutes before class?
Sure,
Man, do more left.
It'll be quick.
okay. I mean, I also have a break at
I was
11.
gonna ask you about my book, just real briefly on alpha in, alpha out,
Okay,
all that, because I was taking the test and I lost it.
okay.
I didn't have enough of it.
I also have a break from 11 to noon
Yeah, I
today.
got your
So,
book, but I don't know which one it is, so I can give you one.
Yeah, I think it's like 13. All that, it's the later one, like that.
I'll just-
That's my favorite one. Here's my float. I didn't have a float.
This one. This contact normally open. So we're gonna close it.
There should be a more
Current one,
closed one.
current one still is here. That's open. But there's, you need to assign something, this one, here one.
Save a little bit.
okay, sounds good.
Another contact.
Do another contact. So, okay. I think if you.
Yeah, I think I'm confused because I'm combining two objects. Okay.
Okay, now, push the button, as long as it's closed here. Then it will work. Yeah, okay. And then we're gonna do more contacts here. But later
On
on,
another line.
add another line for the temperature.
So I need another contact, relay contact for the temperature on this other line.
Label that one. And get that one, see that here, too. What does CW stand for?
Holy water.
Oh, it says right there.